This is the circuit for the voltage divider. We will be using resistor 1 and resistor 2 in series. The power will be provided by the function generator. Our voltage measurements will be made with the oscilloscope. We will use the Agilent multimeter to measure the resistance of R1, which we will use in our calculations, and the resistance of R2, which we will use to compare our final result. So first we will measure resistance. Power on the multimeter, select your resistance setting, measure the resistance of R1, 3.3755958 kiloohms. The resistance of R2, 1.0262 kiloohms. That is all we'll need the multimeter for today. The circuit consists of two resistors in series. Power will enter here, flow through resistor 1. We will connect it to resistor 2, flow through resistor 2, and then return to the power supply. Here's resistor 1 and 2 in series. Connect our function generator to the high side of resistor 1. And return from the low side of resistor 2. Our circuit is complete. We can power on our function generator with the power button here. We can choose a sine wave, a square wave, or sawtooth wave. Here we choose a sine wave. The output level is controlled by this knob. The frequency is controlled with these coarse and fine adjustment knobs. We will be going to approximately 2,000 hertz. Our voltage measurement is made with the oscilloscope. Voltage is measured vertically on this scale. There are 8 divisions in the vertical direction. Time is measured horizontally. There are 10 divisions horizontally. We can measure 2 channels of voltage, channel 1 and channel 2. We will use both today. Channel 1 will measure the voltage in. We will measure the high side of resistor 1. This gives us the total voltage in the circuit. We want this voltage to be 8 volts. So first I'll adjust my frequency to 2,000 hertz by moving the coarse control knob. And then we will adjust our output to give us our desired peak-to-peak voltage. Peak-to-peak voltage is measured from the bottom of the wave to the top of the wave, lower peak to the upper peak. In this case, on channel 1, I have a scale set for 1 volt per division, and the wave is taking 1, 2, 3, 4, 5, 6 divisions. That is 6 volts. 6 volts per box, 6 boxes. 1 volt per box, 6 boxes. We'd like 8 volts peak to peak. So we will increase the voltage using our output level on the function generator until the wave reaches from the bottom to the top. We are also interested in measuring the voltage across resistor 2. We will do that on channel 2. Plug the high side of channel 2 into our resistor 2, high side here, and then we change the display on the oscilloscope, moving down to channel 2. To make a precise measurement on the oscilloscope, you should adjust the scale so that the wave takes up as much of the screen as possible. Scale control for channel 2 is here under the channel 2 controls. Currently we're set for 0.5 volts per division here. If we move to 1 volt per division, you see the wave shrinks. The voltage doesn't change, just the display. If we move to 0.2 volts per division, we can reposition this wave using our vertical control. We can see that the wave is just off the top edge of the screen. So 0.2 is the wrong scale. We'll back down to 0.5 volts per division. To make this measurement from peak to peak, first you use your vertical control knob to put the bottom of the wave along one of the horizontal rules on the oscilloscope. Then you use your horizontal control to move the wave left or right and align the peak along the central ruler of the oscilloscope. Now we can count divisions. from the bottom of the wave, 1, 2, 3 full boxes, and then some fraction of the next. Here it's 0.3. So that is 3.3 boxes, or divisions, at 0.5 per division, which results in a voltage measurement of 1.65 volts on channel 2. Up next, we will look at part 2 of the experiment, which includes a variable resistor, a nickel-chrome wire.